Okay, here's my very short video on experimental and theoretical probability. So the main difference is theoretical probability is what's supposed to happen. Whereas experimental probability is what actually happens. And so the best thing I know to do to simulate this is look at flipping a coin. So if I flip a coin 10 times, how many times am I supposed to get heads? Hopefully you say 5 times I get heads and 5 times I get tails. Meaning I get a 5 in 10, which is 1/2, which is 50% chance of heads, or a 5/10, 1/2, 50% chance of tails. And that's theoretical. That's what's supposed to happen. So this is in theory, theoretical. Now let's say I actually do flip a coin 10 times. And so now I go into the realm of experimental. And when I flip this coin, I get 6 times I get heads and 4 times I get tails. That doesn't mean I did it wrong. It just means it didn't act as it was supposed to in theory. And so my new probability is 6 out of 10 and 4 out of 10, which if I simplify that becomes 3/5 and 2/5. So I have a 3/5 probability of getting heads and a 2/5 probability of getting tails according to the experiment. But that never changes the theoretical. The theoretical of a coin is always 50-50. There are 2 possible outcomes, and each possible outcome has an equal chance of being picked. So let's just kind of talk about this a little bit. Look at a cube, for example, a number cube. And when I talk about a number cube, I mean the typical one which has like 1 on one side, and then 2, and then I don't know if this is accurate, but 3 on another side, and 4, 5, 6, etc. And so I want to know what's the theoretical probability that I roll an even number. You may see this as probability even. So go ahead and try this. Okay, hopefully, so pause it if you want to give it a try. Okay, hopefully you paused it and tried it. Let's see if you were right. We're going to hit play. Well, on a dice there are 6 outcomes, 6 possible outcomes. You could get a 1, a 2, that's not a 2, a 2, a 3, a 4, a 5, or a 6. And I want to know the even numbers. Well, there's 1, and there's 1. So I have 3 out of 6. So in theory, my probability of getting an even number is 1/2, or 50%. And so that's great. That shouldn't be too difficult to understand. Let's move it just a little bit of a step up. We're going to keep largely the same situation here. We've got a number cube. The only difference is now we have 2 of them. So we have 2 number cubes. And what we want to do is we want to find out the probability of getting a sum of 5. So the probability of sum 5 on the 2 die. So actually let me put that sum of 5 on, on 2 die. Or is it dice? I can't even remember if it's die or dice. We'll call them cubes. So what's the probability of getting a sum of 5 on the 2 cubes? Well, hopefully you can see that there are 36 possible outcomes. 36. Why? Because, well, I've got 6 possibilities from cube 1, and I've got 6 possibilities from cube 2, and we learned the other day that if I need to have 1 out of those 6 possibilities and 1 out of those 6 possibilities. Fundamental counting principle tells me there are 36 possible outcomes when I roll the 2 dice. And what I want to do is I want to list all of the different ways that I can get a sum of 5 on 2 cubes. So I could do 1 and 4. I could do 2 and 3. And that's about it. But keep in mind, I have 2 separate dice here. And so I could have rolled a 1 on the first die and a 2 on the first die, and then a 4 and a 3. Well, I could also have that switched, right? I could turn around and roll a 1 or a 2 on the second die with a 3 or a 4. And so that's a different outcome because the first die had 1, 2, 3, and 4, and the second die had 1, 2, 3, and 4. And so there is 1, 2, 3, 4 possible outcomes to get a sum of 5 out of those 36. And so once I simplify that, I get 1/9. And so hopefully theoretical probability is something you've done a whole lot before, and you shouldn't have to think about it too much. Something that may be a little more difficult that you might not have done before is bringing combinations into the mix. Now we're going to get a little fun. So let's say we have a standard deck of 52 cards, and I want to deal out a 5-card hand. You know, like in 5-card stud poker. So a 5-card hand. I want to know what's the theoretical probability of being dealt 2 7s in this 5-card hand from a standard 52-card deck. So let's talk about what this means. In a 5-card hand, 1, 2, 3, 4, 5. If I want exactly 2 7s, oh, that's the key there. It wants exactly 2 7s. So if I get 4 7s, that's not good. I want exactly 2 7s. So if 2 of these cards are taken up by 7s, that means 3 of these cards are taken up by everything that's not a 7. And so we have to look at both of these events. And so we want to use combinations that we learned about the other day. So there are, I want to figure out the number of combinations of 2 7s I can have. Well, in this 52-card deck, there are only 4 7s, right? And so, basically, I want to do 4C2. That'll tell me the number of combinations of 7s. Combination of 2 7s. Not 27s. That's of, let me write it, 2 7s. Of 2 7s. And then the rest of it, if I take the 4 7s out of the deck, I'm left with 48 cards. And so if I have 48 cards and I need 3 of them to be non-7s, that'll tell me the combo of 3 non-7s. And so those two combinations tell me how those 5 cards can be made up in the deck. But the thing that I need to realize about all of this is there's a bunch of combinations, right? If I have a deck of 52 cards and I have to draw out 5 of them, that'll tell me all the different combos of 5 cards. Combo of 5 cards. And so now I need to kind of bring this all together. Well, remember, we're going to multiply what we want and then divide by what we have. And so you would take 4C2 times 48C3 and divide that by 52C5. When you do that, you end up seeing that you don't have a very good chance. You have a probability of exactly 2 7s. That will only equal 4% roughly. So not very good. So there's a couple questions on your homework that I want you to try this from. I totally expect you to ask the questions in class, and that's okay. There's one more thing I want to show you at the end before I conclude the video, and that is using a simulation. But I will actually show you how to use a simulation to predict outcomes in class. It's going to involve using your calculator. So give your homework a try. You'll do fine. If you have any questions, shoot me a Canvas message. Goodbye.